In this video, I am going to talk about thermodynamics. It's a very important topic in physical chemistry. If we look at this term, that is thermodynamics, then we can see that it's a combination of two words. One is thermo and another is dynamics. Thermo indicates about transfer of heat, and dynamics is related to a system or anything that is in the motion. Therefore, thermodynamics describes macroscopic properties of equilibrium system. Now we have to know some macroscopic properties. Some macroscopic properties are like temperature, energy, and entropy. Now we have to know what is system. System is a very important term in thermodynamics. The part of universe that we choose to study is called system, while the rest of the universe is called surroundings. And this surface that dividing the system from the surroundings is called boundary. In thermodynamics, system can be open, closed, or isolated. In case of open system, both mass and energy can transfer from surrounding to system and system to surroundings. In case of closed system, energy can transfer from system to surroundings and surroundings to system, but mass can't do this. And in case of isolated system, neither energy nor mass can transfer from surrounding to system and system to surroundings. Now we have to know, depending on the mass, system's property can be two types. One is extensive and another is intensive. Now, what is extensive properties? It depends on the mass of the system, like number of mole, volume, etc. And intensive property that are independent of mass of a system, like temperature, pressure, Weber, etc. Now we will know how to define the state of a system at equilibrium. It is defined by the collection of all macroscopic properties that are described by a state variable like pressure, number of mole, temperature, and volume. It also noted that the state function of a system is independent of the history of the system, that is, independent of the path. For a one component system, all is required is n and other two variables, then all other properties follow, like v is equal to f of n p t. Those n p t are variables of a system, or p is equal to g of n v t. This n v t also the variables of a system. Here 3H2 G1 bar 100 degrees centigrade. Here 3 stands for mole, that is n is equal to 3. G stands for gas. We know that bar is the unit of pressure, so P is equal to 1 bar and T is equal to 100 centigrade. Now we will know the change of state. Basically, change of state is like initial to final. Suppose here 3H2 G 5 bar 100 degree centigrade. This is the initial condition, and in final condition we get 3H2 G 1 bar 50 degree centigrade. So the sequence of intermediate states is like that. Now we will describe process with respect to path. Number 1, reversible. If a process is a reversible, then always it is in an equilibrium. That means if we get A from B, that means A is a product and B is a reactant. Consequently, we also get B to A, that is A to B, B to A. In case of irreversible, irreversible process defines direction of time. I mean, in this process, we will get only product, but product can't return to reactant. In case of adiabatic process, no heat transfer between surroundings and systems. In case of isobaric, iso stands for constant and baric comes from bar, that is the unit of pressure, so constant pressure, and isothermal is the constant temperature.